All right. Now that we are officially 1 minute past, I think it is time for us to get started with these lightning talks. I am super excited to get to hear all about data sharing practices today. And so our first presenters will be Rachel Opitz and Ingo Simonis from Open Geospatial Consortium. So feel free to share your screen and begin your talk when you're ready.
Okay, hi, I'm Rachel Opitz from the Open Geospatial Consortium, and thanks to the organizers for inviting us here today. So I am going to be talking to you about a project that's really just at its beginning stage as you're celebrating the end of the big year of open science, looking at designs for a platform to enable and motivate open geospatial science. So for those of you who don't know about the Open Geospatial Consortium, the OGC, I thought it would be helpful to say a little bit about who we are. We are a not-for-profit membership community. We have more than 550 members all around the world who spend a lot of time making geospatial technologies that help to move data around, enhance it, analyze it, share it. And so our community is really the motivation for the development of this system and then all of the people who they serve. The other thing that glues the OGC together, which you may have heard of, is our work on geospatial data standards. So we're an organization that develops and promotes community consensus-based standards for the sharing of geospatial data and the formats of geospatial data and geospatial technologies. And we're doing a lot of work on the development, particular of APIs as enabling technologies for data sharing and analysis and exchange. So we have a very particular challenge in our community. Our OGC Collaborative Solutions and Innovation, this is the program I sit in, our initiatives and our community members, mostly our community members, produce literally thousands of applied research projects every year, code, data, services, reports, all of which leverage geospatial data. And most of our members, probably all of our members, really want to use open science and adhere to FAIR principles so that they can work more effectively and so that their work can have greater impacts. This is a really hot topic in our community. And when we thought about starting to build a platform to help our community to follow good open science practices and really leverage the strengths of those methods, we found ourselves really trying to think about what unique contribution we could make and focusing in on a community of users and our members who need both standards conformance, so really following these published data and technology standards, and who need to use FAIR data and who need to follow open science or benefit
What?
from open science. And we
Dr.
really
Yes.
see that group as being people who are often sitting in positions of public trust, so researchers in government organizations, in nonprofits that might support those government organizations, or in companies who work in service of those organizations, because these are places where you're often required to adhere to standards and you really have to be able to demonstrate data provenance. You need to have transparent and reusable services. Things need to be portable, and you need to be increasingly following FAIR data standards. So those were some of the things we were trying to look towards. In terms of geospatial data, we tried to consider what some of our community's special challenges are. Geospatial data is notoriously very large. Think of the petabytes of data that are created by satellite imaging, and they're also frequently updated. So we have often a temporal refresh rate on a couple of days, and they come from very diverse sources. We have workflows that then use data and services that are often distributed across multiple platforms. We have applications across a really wide range of domains, everything from health to climate monitoring. And critically, seemingly unconnected data and services are often linked by location. So think about the link between child health and the location of traffic lights. Only location might tie these things together. You wouldn't semantically link those domains necessarily. But these connections can have real world impacts if you think about traffic idling at that traffic light and then impacts on child health. So how can we build a platform that deals with geospatial special needs and does these other things. So this is where the current project, the Open Science Persistent Demonstrator, comes in, sponsored by our colleagues at NASA and ESA, the European Space Agency, to whom we are very grateful for their support. And what we are trying to do in the Open Science Persistent Demonstrator is really to make these links between what we see as the needs of these people who are working in these positions of public trust that I described before, and what can be provided through geospatial data and analytical services. So making this connection between that public user and what we call data and service and platform providers. And we see our end users as really needing knowledge, being able to do things like protect against landslides or flooding or optimize traffic, and our data and service providers who can give data, metadata, processing power, and information on data quality and provenance, which is quite important for these applications in a public trust sphere. So we started to look at our individual challenges and really turn them into design principles. So saying, okay, if we have very large, frequently updating data, we need to prioritize data by reference and data as a service with a lot of versioning metadata involved. If we have workflows that often use open data distributed across multiple platforms, we have to require conformance to a core set of standards for interoperability. If we have applications on lots of different domains, we might need to have intended scope of application as part of the metadata. So what you should and maybe should not do with the data set. So kind of appropriate terms of use, terms of service. And we are going to have to connect data and services based on spatial, temporal, and semantic dimensions, as I was discussing before. So very briefly, giving a bit of an overview of our infrastructure, we are building a distributed infrastructure with 4 key pillars. We have standards, conformance, and evolution being supported by the OGC itself. So that's really our role. We are partnering with the Center for Open Science to use the OSF for metadata enrichment, archiving, and discovery of platforms, services, workflows, and what we're calling workflow instances, so executed workflows. We are supported by our large and wonderful community of members who are providing data and services. And then we are using the Galaxy project for workflow prototyping, composition, and orchestration. So really building workflows that work across multiple platforms by leveraging OGC API standards. So really taking this community of potentially interoperable platforms and making them truly interoperable by using Galaxy to build a bridge. So the OGC standards and APIs that are the foundations of this, in particular in this project, we are focusing in on OGC API processes and features. So you see here kind of a range of APIs, as well as the Stack API and Stack standard for data cubes, and the Geodata Cube standard for all of the raster data that we use in a lot of these workflows. So in terms of our engagement with OSF, we are really seeing them as playing a key role in the part of our workflow where we are going to be helping people to discover different workflow components, different services, and workflow instances. So examples of how people have built workflows before by creating registration templates, really enriching these digital artifacts with metadata, and then registering DOIs for them and linking them to the DOIs for OGC standards and best practices documents. So that's a piece of work that is going to be upcoming over the next year. We are going to be using Galaxy as our workflow environment, as I mentioned. Galaxy is great. It provides a low-code graphical user interface to support scientists. They do a lot of peer review of tools and, importantly, community support for training, and they enable export of workflows to CWL, the Common Workflow Language. So that, again, is hopefully going to help us to get data moving via workflows. We are, you don't need to read this slide, particularly, as I said, focusing on OGC API processes and really implementing that into Galaxy. So that's a bit of software development we're doing to put this system together. That is in process, but the idea basically is that you will be able to send data or an analytical command to run on that data between Galaxy, the Galaxy ecosystem over here. I don't know if you can see my mouse or not, and the Galaxy OGC and the OGC API process provider over here via a wrapper in the middle. So that is what we are doing on the Galaxy side. So we've got OSF and then we have Galaxy. So we are at the point where we are building out our user journey to help to understand how a scientist, for example, could move across this ecosystem we are building. So we are building it for workflow contributors, app developers, and scientist researchers. We are really trying to think about why people should contribute, platform and service providers increasing their visibility and growing their user community, and applied and public trust research users having an easier time building workflows and being able to support traceability, integrity, and provenance, hopefully leading to trusted data and workflows. So if you want to learn more, please join us at some of these upcoming events, and I will stop there because I believe I am out of time.
Fantastic. Thank you so much. All right. We now have Isaiah Lynch and Frank Bosco from Virginia Commonwealth University.
Hi, everybody. My name is Isaiah Lynch, and today I'm going to be talking about the process of verifying Metabus. Metabus is a data curation project in the field of applied psychology. I'll talk about that a little bit more in the future, but for now, let's first talk about what it's like to conduct a traditional meta-science study. The process is quite tedious and time-consuming. On the right, I have an example from 2001 where the authors had to manually curate and sift through 11,000 studies to conduct their meta-analysis. Obviously, there's a 23-year difference, so you can imagine what that looks like nowadays. But these studies are quite valuable. We place them at the top end of the hierarchy of evidence, so there's a lot of room for improvement. One way of improving it is applying the FAIR guidelines, which are findable, accessible, interoperable, and reusable. So now let's talk a little bit about Metabus to kind of talk about where we started from. Metabus started in 2010 and represents over 1.1 million manually curated findings, again in the field of applied psychology. This is the largest non-automated extraction effort in the social sciences. Along with the curated finding, there's also a hierarchical taxonomy of 5,000 constructs. So the constructs are given a unique name as well as a unique 5-digit identifier. Through Metabus, you can conduct instant meta-analyses, and there's currently 1,300 users, a little bit over 1,300 users on the website. So to kind of show that off a little bit, to show you where we were at before we verified Metabus, I'm going to walk you through a demonstration. This first part is the taxonomy. I typically like to show off the big 5 traits because they're pretty common across different fields. So the big 5 are personality traits, so that's a person characteristic. It's psychological, it's a trait, and then we find personality, and then there's the big 5. So if I hover over conscientiousness, you're going to be shown the unique name, which again is conscientiousness, the unique identifier, which is 20438. And then you see it's really small, but it says 18,446 records. So this is any correlation between conscientiousness and any other variable in the Metabus database. If we go over here to extroversion, we're again shown a new unique identifier, which in this case is 20439. And again, the records, which sits around 18,000 for extroversion. There's also this search where you can search the strings or the numbers to find the constructs in the database. If you use Metabus enough, you end up using the numbers. They're kind of ingrained in your head. So now that you know how to find what's actually in the Metabus database, you can go over here to the targeted meta. The targeted meta takes 2 different variables and does an instant bare bones meta-analysis. So let's type in conscientiousness over here and extroversion over here. You can either use strings or those unique number identifiers. So again, conscientiousness is 20438. All I'm doing here is typing a comma and then that unique number. And then extroversion is 20439, again, just a comma and the number. We typically suggest that you use the numbers, not the strings. For things like age, Age as a string is represented in a lot of different words, so you'll come up with a lot of errors in your data. After running this query and after some time, it has to speak with the Amazon servers, you're presented your results from the Metabus database. The website will only show 1,000 effect sizes, but I'll show you how to download the full effect sizes in the Metabus database in a little bit. You're showing your mean R as well as confidence intervals, and this is furthermore represented in a plot down here. You're showing your overall effect sizes from the samples it's from and the articles it's from, and your overall N, as well as reliability and response information for the two variables and publication year, and then sample sizes down here. If you scroll down, these represent author-reported construct names. So this doesn't matter much for Big Five, but if for some reason you don't want conscientiousness honesty in your sample, you can go over here and click remove. And then if you scroll down farther, you can download these results. That will download all 1,500 records rather than the limit to 1,000 for the website, as well as allow you to do more data analysis and cleaning methods. And then if you click on this world map tab, you can actually see where your data is from. So for conscientiousness and extroversion, 570 of these are from the USA. Now that we see where we came from, we're going to talk about the process of actually verifying the Metabus database. So verifying Metabus required 3 different websites that did 3 different things. The first one is BioPortal, which houses the controlled vocabulary / ontology. That was just the taxonomy I showed you, and it takes it from this format into this format over here. There's several benefits for this. Again, if you think about the Big Five, a lot of fields study the Big Five. So if another field wanted to create a taxonomy around the Big Five, they could borrow our taxonomy, as well as just making general cross-field comparisons about what's studied in the fields. The next website is CEDAR, which houses the metadata schema. Metadata schema is just the rules. So the example I like to use is response rate. If you're given a response rate above 1, that obviously is impossible. So CEDAR will tell you no and give you an error. CEDAR can also talk with BioPortal. So when you're asked to enter a construct name, what's actually giving you is values from the ontology housed in BioPortal. The predecessor to this for Metabus was just simply an Excel file, but you can imagine that this is pretty hard to share and make open to users, while CEDAR is much more open and available to users. So if someone is using Metabus data and they want to see possibly how it was collected, what certain variables mean in the Metabus database, they can find this more easily in the CEDAR format. The last one, we're still working on this, but this would be housed at the Center for Open Science. The Center for Open Science would house the metadata instances. In terms of Metabus, this would just be the correlations between 2 variables, which is obviously being housed at Metabus currently. The Center for Open Science component would be able to talk with CEDAR and BioPortal such that the end user could conduct instant meta-analyses at the Center for Open Science website. So going through that and talking about that, I also just want to focus a little bit on the benefits of doing this and why you should consider doing this for your own research. This allows for more efficient research curation, dissemination, and cross-field comparisons. So again, back to the Big Five example, if I was a personality researcher and I wanted to do a meta-analysis on the correlations between the Big Five traits, it'd be quite hard for me to find applied psychology findings because that's not my field of interest. I wouldn't know what journals to search, what search engines to search. But since they're all uploaded to the Center for Open Science website, it'd be much easier for me to find those and use that in my sample for the Big Five traits. In terms of curation, because CEDAR sets limitations to what data is acceptable, we can imagine in the future that individual authors can enter their data through CEDAR and it would be incorporated into the Metabus database, which would obviously be much quicker than the current system. Obviously, this would require some oversight because there was quite a bit of training for the Metabus database, like entering data. It also would help with dissemination, making it much more open. Additionally, this goes beyond just metadata. As I talked about with ontologies, you can share ontologies, take inspiration from our ontology, and just in general look at comparisons between fields. Lastly, this allows for more permanent means of data storage. BioPortal specifically uses permalinks, so will the Center for Open Science. So through permalinks, it's much more permanent. To end this off, I just want to give you a few links. At metabus.org, you can find a couple papers on the motivation and process of building metabus, such as the creation scheme. You can also find information on the creators of Metabus. At shiny.metabus, that's what I just showed you, running the instant meta-analysis and showing you the taxonomy. So if you want to go there, all profiles are free and you can just interact with the data. Lastly, the BioPortal link there is just a link to the Metabus ontology on the BioPortal website. So if you'd like to follow in our footsteps, you can see how we did it. And thank you. That's all I have.
Fantastic presentation. Thank you so much. Next up, we have Christine Kirkpatrick from San Diego Supercomputer Center.
So the speaker list should have been updated. I'm here on behalf of all of the group. I'm Katie Knight from Oak Ridge National Laboratory. Let me share my screen.
Sorry about that.
That's okay. Christine and I are both part of the GoFair US office, and I'm here to talk about records-based repositories, but I want to situate this in the broader context of where this work came from. So since December of last year, GoFair US has been partnering with NIAID. If you're not familiar with NIAID, this is the National Institute of Allergy and Infectious Diseases. They're under the National Institute of Health, and their focus is preclinical and clinical research to help with the development and testing of new and improved vaccines, therapeutics, diagnostics for infectious and immune-mediated diseases. And so the data from the research areas is quite large and broad. It's stored in a number of NIAID or NIH-funded repositories, knowledge bases, data management centers, other data resources. And so this is a big effort. I'm the one here talking, but Christine is leading this effort, and there's a lot of people involved. So I want to be clear, this is most certainly a group effort. Broadly speaking, our goal is to help with NIAID data resource usage across NIAID teams, facilitate secondary research, and help with their scientific impact. Specifically, the tasks are reviewing the compatibility of the data sets within their data ecosystem discovery portal, specifically looking at the ability of NIAID researchers to share data, use tools, reuse workflows, what type of computational capabilities they have and are necessary, maybe even review whatever verification solutions are currently in place at NIH and whether they can be leveraged for the NIAID repos, provide some training, and then some umbrella activities, including analysis of scientific impact, interviews, such things. And so out of this activity, we noticed that quite a few tools that are available for assessing the fairness of repositories focus on file-based repositories as opposed to records-based repositories. And so this has resulted in a white paper, which is currently being written, that John Graybiel is spearheading, that a lot of other people are involved in the writing of. And I'm going to talk to you about that now. So talking about where this came from, the practical interpretations of FAIR tend to assume that the primary organization of data is a data set, which is reasonable, but this tends to, you think of it as like a file or maybe a group of files. Whereas with records-based repositories, you don't really have metadata about the aggregation of dynamically generated data. So if you think about your file-based repositories, you've got something that principally manages data as files or collections of files where the metadata is describing the data files as a whole. Whereas with records-based, you're thinking of repositories that manages data as atomic records that are dynamically aggregated into a collection or maybe a report, probably in response to something that a user has put in. So think stream-based or time series data, triple stores, if you're familiar with triple stores or graph databases. And the metadata might describe the entire collection as a whole, but you're not really getting what that granular data may entail. So some considerations about records-based repository, the core entities. And so what I mean by this is how you would fill in the blank when you say, I'm giving people access to data about X. What concepts from ideally a controlled vocabulary is describing the entities? And these repositories would also have something called secondary entities. So what else do you need to keep track of as it relates to X? So maybe some type of characteristics. For instance, if you have a data repository about tissue samples, you might also want to understand the processing procedures that are related to those samples. So if you think about it this way, the metadata you're thinking of that you need to make data findable, accessible, interoperable, and reusable should fully describe how the data is being generated. And that dynamically generated data, you also need to understand what those user-provided constraints, filters, and queries are. So then you can also preserve the conditions, the actual query, the filters, the constraints, and versioning so you can later easily replicate the data. So some recommendations that we have in this white paper tend to focus on the identifiers, which is not surprising. Most of FAIR is to provide things with machine reproducible data. And so ideally, you have globally unique, persistent, and machine resolvable identifiers that are also easily exposed. So for instance, when you have aggregated that data and the data gets exported, then that is mapped to some type of external identifier. Ideally, also, this identifier is resolvable. So that the data set is associated with an actual entity. It's not just an arbitrary identifier that's internal and not really usable by somebody else. Something else to consider is that with records-based repositories, the data itself may change over time. And so even having the quote unquote recipe for that data may not be especially useful if you don't understand the data as it was at state at time when the query was done. So trying to think about a strategy for representing that, that data at any given point in time when a query is executed is also useful. Consideration for any type of customization. So if you have like very specific constraints that are maybe particular to a study, considering how you might associate those constraints with an identifier. So those are also easy to understand and parse later. Agreeing on terminology. So in the previous talk, using something like CEDAR or some other controlled vocabulary. So if you're all using the word phenotype, for instance, everybody agrees what that means and that there's an easy way to dereference that and understand it. Considering the specs as a community for how you're exchanging your metadata. So make sure that the way you're asking others to consume your metadata is cleanly documented and maintained either by a standards organization, or if that's not possible or available to you, that within your community, you agree on some sort of specification so it's easy for others to make use of this. We also recommend providing common services like search and common access methods. So considering maybe even your data format, so you're not providing people with data in a format that's not easily used by them. So ways to consider evaluation: what type of data products are you giving access to? So for instance, how do these line up with FAIR? Considering your own repository as it is right now, where does it work with FAIR? What does it not necessarily work with FAIR? Specifically, how is your repository, if it's a records-based repository, handling the creation, sharing, and resolving? Can you version these on-the-fly data sets that you're generating? And then also consider if you are part of a larger data ecosystem, which I think a lot of our research domains are. What are the other entities in your, or not entities, other repositories or knowledge bases in your ecosystem? Consider FAIR. For instance, is everybody using the same controlled vocabulary? Are they using controlled vocabularies at all? If you want to know more, this white paper is going to be included in the final landscaping report. It will also be published and put on archive in a short version. And then we will also share it with anybody who is subscribed to the Go Fair US newsletter. If you're not a part of that, please join this conversation. This is most certainly a group activity, and we'd love to know more from the community. That's it for me. Thank you so much.
Thank you so much. What a great job. We will now have Alberto Acamazzi, from SciEx, the NASA Science Explorer.
Okay, thank you very much. So my name is Alberto Comazzi. I'm the principal investigator of the Astrophysics Data System, and I'm here today to talk about the NASA Science Explorer, which is a new initiative that we launched this past December. So we'd like to spread the word and explain how this relates to open science initiatives across of what NASA is doing and at large. Okay, so what is the NASA Science Explorer? It's the easiest way to describe it is a discovery portal. It was launched at the AGU meeting in December 2023, and it represents an expansion of a system that has existed for over 30 years, known to every astronomer as the Astrophysics Data System, which is a digital library focusing on space science research. It was originally only focusing on specific astronomy and astrophysics content, but it was then enlarged to include more disciplines related to astronomy, such as planetary science and solar physics. The other way to provide a quick description of SciX is that it's a literature-based open digital library system that unifies the different research disciplines funded by the NASA Science Mission Directorate. And there are 5 such disciplines. I'll show you in a moment. So the innovative aspect of this digital library is that we are specifically charged with unifying them in an interdisciplinary setting. And of course, we're doing this in the spirit of open science. So there's a variety of open science initiatives within the NASA portfolio, and interdisciplinary research and collaboration is one of them. It is now available as a beta release of what we plan to launch later this year at the next AGU meeting. So with that provision, it's already a resource available to everybody. Here's the URL, sciexplorer.org. And we are, of course, continuously adding content to it, but it's already quite a mature platform for people interested in space science research. So let me just briefly go over some of the main motivating factors that have led us to the creation of the NASA Science Explorer. In 2019, the NASA Science Mission Directorate published a strategic plan for data and computing support. And that report identified the need for an interdisciplinary literature portal that would span across these 5 research areas, which are Earth science, planetary science, heliophysics, or the study of the sun, astrophysics, and biological and physical sciences as studied by NASA. So in the context of astrobiology and experiments on the International Space International Space Station. The ADS project was selected for its support of open science initiatives that, as I said, we carried out on behalf of the astronomy community. And we've done this for a number of years, identifying and cross-linking open access publications with journal publications, data sets and software through aggregation and metadata enrichment. So over the next 3 years, we will develop and expand a program that will incorporate more of the content in the disciplines not covered so far, in particular, earth science and biological and physical sciences. So with respect to how this relates to open science and FAIR principles, the main argument and the value that we bring to the table for in support of research initiatives is that we are aggregating discipline-specific content, which goes beyond the traditional literature journal articles. So here is an example of some of the publications that are represented as records in our system. As you can see, you have the normal conference proceeding papers and journal articles, but also a number of abstracts and talks submitted to conferences such as the AGU and the American Astronomical Society, the so-called gray literature that includes PhD theses, technical reports, and finally things such as funded proposals and observing proposals, newsletters, and finally software and data sets have been additions that we added most recently. The other aspect of FAIR principles is, of course, to use well-known vocabularies and taxonomies to actually label the records and the data sets we're interested in. And so this is an example of one of the taxonomies that we have adopted that is used to identify planetary feature names as found in the solar system. So this is a standard taxonomy, and we are using machine learning techniques to automatically label articles with the separate features that are named in those articles. And another distinguishing feature of the system is that to the extent that we're able, we will always try to link the literature to the data sets. So articles in our system have links to the data sets that were used or produced in the study detailed in the article. And finally, as we all know, different disciplines will have specific needs for different research filters and capabilities. So customized options will be available to typically search the system using keywords to find papers on specific topics. You can look up people themselves, so you can look for topics, peoples, but also other associated metadata that we index, such as organizations, where we use standards such as ROR to uniquely identify organizations. And then, as I said, research-specific items such as astronomical objects in the case of astronomy. I already mentioned planetary names and so on. So each discipline will have discipline-specific features in the search that we support. After you find the literature of interest, then you have a variety of options available, including generating metrics, so studying, understanding better what the distribution of papers over time or citations. You can visualize collaborations of people working on particular topics, if that's what you're looking for. Extract topics from a set of paper to have a better sense of what are the concepts being discussed in a variety of papers. And you can then generate and download bibliometrics and analytics data to do further research. When you find records of interest, you also have available at your disposal a number of related links. So for each paper in our system, we track citations, so you can look at the references, so the literature, the cited literature from that paper itself, and then all the other papers that cite that particular record or data set. And for each resource, we also, as I mentioned, have links to data products and software. So in this case, I'm showing links to the planetary data system data set that is available for this paper. And so if you click on that link, you will be taken to another external archive, in this case, the planetary plasma interaction node of the PDS. So in conclusion, the motivation behind the creation of this new platform is to, again, unify all of the research that NASA, all of the research area that NASA funds, connecting into data sets. So not just data sets hosted in NASA archives, but all the data sets relevant for research in a particular field. And also adding links to the code that was used in each paper. We think this is going to produce a better result than what is already existing. First of all, this is an open system, and it has an open API. The website is open to everyone, but also it's open in the sense that we accept and solicit feedback from the community in terms of what features need to be incorporated, and we accept corrections whenever some incorrect record is found. It's trustworthy, complete. We aim to be complete and not leave people wondering whether everything that they need was found or not found. And most importantly, interdisciplinary and developed by scientists for scientists. So with that, I stop here. If you're interested to know more, you can follow us on X and the other social media, as well as leaving comments from our website. Thank you.
That was very informative. Thank you so much. And now we'll have our final lightning talk from Tracy Weisgerber from Quest, Center for Responsible Research.
Okay, thank you very much. And thank you for the excellent moderation of the session as well. Okay, so tonight I'm going to talk about going beyond the FAIR principles and the importance of expanding the conversation from can I reuse this data to should I reuse these data? And the content that I will talk about tonight are also outlined in an editorial that was actually published in Nature Medicine today. You may have wondered if I planned to have this editorial and talk on the same day. I did not. This is purely accidental, and I'm sure it will never happen again. But if you would like a written version, you're welcome to check this out. And I would also like to emphasize that I'm presenting on behalf of the many co-authors who worked on this piece and whose names you can find here and on the correspondence piece. So I'd like to start off this evening with a thought experiment. So let's say that I share some open and fair data so that all of you can reuse that data. However, there are a problem because while my data are open and fair, there are problems with the way the study was designed and conducted. Perhaps it's poorly designed, it's not rigorous, it has a high risk of bias, or for other reasons is likely to yield untrustworthy and reproducible findings. So each of you then reuse these data to generate your own findings, which are similarly unlikely to be trustworthy and reproducible. And in one sense, we have a success because we have lots of people reusing data to generate new knowledge. On the other hand, probably all of us would be a little bit uncomfortable with this, maybe very uncomfortable, because we would know that if the reusers didn't or couldn't account for the design problems when they were conducting their reanalyses, the findings are unlikely to be trustworthy and or reproducible, and this would not benefit science or society and could actually cause harm. So, what do we learn from this? Well, one of the things we might learn are that openness and fairness are not markers of rigorousness, trustworthiness, or the risk of bias, and most of you probably already know this. We heard a lot in the first talk about the importance of the data provenance, which is consistent with this idea. So when we think about the things from the perspective of the data reuser, we want to remember that researchers can't simply determine whether a data set is open and fair. They also need to consider two other factors that are quite important. And the first of those is the quality of the study design that was used to generate the findings or collect the data. So is it a rigorous design? Is it appropriate? Is it going to give us trustworthy and reproducible data? And then the second is whether the data that were generated are appropriate to answer the research question. It may be an excellent experimental design, but if it doesn't have the features that you need to answer your research question, it's not a good data set for you to reuse. So what do we need to do? Well, we're arguing that we need to expand our approach by considering the responsibilities of the data reuser. So right now we have the FAIR principles, and these have been extremely effective in encouraging people to think about how they can share their data so that others can reuse them. And I think the sessions that we've seen across many different fields have outlined just how effective these principles have been. So the FAIR principles are generally outlining the properties of a data set that facilitate reuse, and these generally track quite closely with the responsibilities of the data depositor. And they help us to answer the question, can I reuse these data? We propose that what we need is guiding principles for responsible data reuse, and these would outline the responsibilities of the data reuser, and they would help us to answer the very important and related questions, should I reuse this data, and how should I use this data responsibly? So if you're interested in helping us to develop guiding principles for responsible data reuse, we are looking for people who are knowledgeable in this area and who would like to be involved. And I would encourage you to send me an email or send me a message on LinkedIn. The second point that we make in the correspondence piece is that responsible data use requires detailed methods. And again, we heard this as well in the first talk tonight. So I just want to emphasize that when we talk about fair data, there's a lot of emphasis on the data and the code, but it's important to remember that we can't use data responsibly if we don't know how they were generated. So if we don't know the rigor, the quality of the experimental design, how different constructs were measured and operationalized, then it's likely that we will make mistakes when we go to reuse that data, and we may end up interpreting results incorrectly or using the data in a way that they shouldn't be used. The final point that we make in the editorial is that detailed methods have independent value, and they are not simply metadata that can be used to contextualize data sets. So I'd like to remind everyone that reproducibility really starts with methods. We can't reproduce or critically evaluate findings if we don't know what was done and how those data were generated. And methods are also really important from the perspective of reuse. Depending on your field, researchers may be much more likely to reuse or adapt your methods than your data. Right now, we have very large communities for open data and open code, but there's been comparatively little attention paid to open methods. And we know that there are groups within the FAIR community that are working very hard on data provenance, on setting metadata standards, that are very interested in this area, and this is critical work. There's one other thing that we have been working on to look at how researchers and organizations can create a culture of open methods sharing, and this is in the life sciences and biomedical research space. This is an initiative called ProMath, for promoting reusable and open methods and protocols, and the objective of this work is to improve the clarity of methods as well as reusable step-by-step protocols in life sciences preprints and papers. And the approach that we've taken is to recommend actions that 4 different stakeholder groups can take to improve the quality of methodological reporting. And the 4 groups that we provide recommendations for are researchers, researchers' institutions and departments, funders, and publishers and editors. We did publish draft recommendations on the OSF over the summer, and those are available at the link that I've provided. And we also did stakeholder consultations with each of the groups over the course of the summer, and we have now revised the guidelines. So the recommendations are undergoing review, and we hope that they will be released in the next few months as a European Commission report. So if you're interested in what organizations can do to improve reporting of methods, I would encourage you to check that out. That's all I have. I'd like to thank everyone, and I wish you a wonderful morning, afternoon, or evening.
Thank you so much. That concludes our lightning talk for this session. Everybody did such a fantastic job, and all of them were so informative. So thank you so much to all of you for being here.